Now remember that in arithmetic sequences, we spoke about the common difference. We said that the difference between each consecutive term in your sequence must be common. So the difference between each term must be a constant value, and we call that difference the common difference, and we denoted it by the letter D. And we said that the common difference must be constant between each term. Now we also spoke about the general formula for the nth term. We said that to find the nth term, it is given by Tn equal to a plus n minus 1 into D, whereby our Tn gives us our nth term. Our a would give us our first term. Our n would be the position of the term, and our D will be our common difference. Now this is for arithmetic sequences. Now arithmetic, remember, are linear, and then series will be the sum of all those terms in your series. So T1 plus T2 plus T3 plus T4 and so forth. Now when we say finite, we are talking about a sum of a finite number. So to find a sum of a finite number, it means that we know the number of terms that we are adding up. Suppose that we want to find the sum of the first 30 terms. Now this is a finite series because we know the number of the terms that we are adding up. So we call that finite arithmetic sequence. And an infinite one will be one where we are adding numbers until infinite. Now we can be given a sequence like this, a series like this, and you don't know where it ends. But if they tell you the number of terms you should add up, then that series is a finite series. The thing about giving terms like this is that what if these terms were 30, like we said here? Are we going to add them one by one, all 30 terms, or the sum of 60 terms? We can't just add all 60 terms one by one, saying 3 plus 2 plus 9. So we have a general formula for the finite arithmetic sequence. Now remember that when I use S here, when I use this notation of Sn, I'm talking from first term. Now I'm talking from term 1. So if I add up term 3 to term 9, Sn will work if T3, I use it as my term 1. So Sn, it always starts with term 1 with whatever terms that you are trying to add up. It is different to sigma notation where you can add any range of numbers. Now our general formula for the sum of infinite numbers, let's talk about the critical values that we usually have when we are dealing with arithmetic sequences. Now the first one will be the first term. We always want to find the first term. We can see that it is also important when dealing with the general formula for the sequence. Now another one that we'll need is n, which is our position of a term in a sequence or in a series. And the other one now will be the common difference, whereby the difference between each term is given by D, and it's equal throughout the arithmetic sequence. Now the fourth one will be the last term. Now if you're talking about a finite series, since you know the number of terms that you are dealing with, sometimes it's in your advantage to know the last term that you are dealing with. Therefore, for our sum that we are going to do, let's say we want to find the sum of a general formula, a general term, and we want to find it from term 1 and until the last term. So let's see, how do we find the general formula? For most South African curriculum, this derivation of the sum of the arithmetic sequence is examinable. Now, what we do is that we are going to take the sum of our terms from the first term. So we start from first term until the last term, whatever that term is. So our first term is denoted by A. Our second term will be A plus our difference, because to move from term 1 to term 2, you take term 1 and add it up with the common difference. So term 2 will be A plus D, where D is our common difference, plus A plus 2D. So you add another D to move to the next term, all the way until you get to last term minus 2D plus, let's say, last term minus 1D plus the last term. Now we are going to take the same terms, add them again, but now in a inverse order. So I'm also going to add another sum of our terms, but I'm going to start with my last term and going backwards, but it will be the same. 2 plus 3 is equal to 3 plus 2. So I'm going to L plus my last term there was L minus 2D. Another term that follows that will be L minus, this is 1D, L minus 2D, all the way until I get to my second term will be A plus D, and my first term will be A. If you add these two sums, what would you get? Now Sn plus Sn will give you 2Sn. Now A plus L, our first term plus our last term, will give you A plus L. Now A plus D plus L minus 1D. Now this D will subtract this one, and we are left with A plus L plus 2D minus 2D. They cancel each other, and then you'll be left with A plus L until you go forward until you reach D minus D, until you are left with A plus L plus this, our last terms there will be A plus L. Now what you can start to notice is that if you add up one sum and then add it to another sum, but in an inverse order, the sums of each term will just give you the same term added together. So we can reduce that and say, okay, we have A plus L, and we have a certain number of them. So we don't know how many of them we have, because you can see I didn't write out all the numbers. So they are times n. It's a multiple of A plus n. Now what I'm trying to solve for here is Sn. So I'm going to divide both sides by 2. So I will have n over 2 into A plus L. Now this is my general formula for the sum of an infinite series, and this is my general formula for a finite arithmetic sequence. All I have to know is the number of terms. I have to know my first term and my last term. Now what you may see to be interesting here is that, let's say our last term. Now every term on our arithmetic sequence is given by this general formula. So if we were to take the last term, it will be equal to A plus n minus 1 D. because this is the general formula for any term in our arithmetic sequence. So the last term will be n, because that will be the number of terms we have in our sequence. Therefore, L can be represented by the general formula. So what if I take that and then I substitute it in my general formula for the sum of arithmetic sequences? So what I will have is Sn is equal to n over 2, and then I still have my a plus L. We substitute the general formula of the arithmetic sequence, which is a plus n minus 1 into d. Now let me simplify this. I have Sn equal to n over 2 into a plus a is 2a plus n minus 1 d. Now this also represents the general formula for the finite arithmetic sequence. So it depends on what you have. If you are given a series in this formation whereby you do not know the last term, this formula, the first formula here, will not be of use to you because you would not know what the last term is. But you would know the general formula to find that last term. So you would come to equation 2 here and use that equation to find the sum of your finite arithmetic series. Now let's do some examples to see how this would work. Now in the first example, let's say that you are asked to find the sum of the first 30 terms of this arithmetic sequence. Now you will know that it's an arithmetic sequence because you can see that if this was an equation for a line, it would be a linear line. So arithmetic sequences are linear. So Tn is equal to 7n minus 5. Now we said that we have two equations for the finite arithmetic sequence. The first one is Sn is equal to n over 2 into a plus L, and the second one is Sn is equal to n over 2 into 2a plus n minus 1 d. Now which one would we use here? Now if we use the first one, we would have to know the number of terms, which is 30. We have to know the first term. We have to substitute T1 into our formula, and we have to find the last term. So if there are 30 terms, the last term is term 30. So we'd have to substitute 30 here to find the last term and then find our sum. Now if we use this one, we just need to find the number of terms, the first term, and the difference, the common difference. Now let's do them both and see if we get the same answer. Now we need to find the first term, a. Now a is given by T1, which is 7 into 1 minus 5. That means our a will be 7 minus 5, which is 2. Now we also need to find the last term. Now the last term will be given by T30 because we have 30 terms. Therefore 7 into 30 minus 5, and that will give you last term is equal to 205. Now the number of terms, we know that the number of terms is 30 terms. So we have all the information we need to use this formula. Now for this formula, the number of terms is 30. We now know that our a is 2, but our common difference, to find the common difference, we might as well find T2, which is 7 into 2 minus 5. Now T2 will be 14 minus 5, which is 9. Now T2 minus T1 will give you the common difference. So we T2 is 9 minus T1 is 2. So our common difference is 7. Now let's find the two sums and see if they give us the same answer. Now S30, we have 30 terms over 2 into term 1 is 2 plus the last term is 205. Therefore, our sum of 30 terms will be 3105. Now, if we use this one, does it give us the same answer? S30 is equal to 30 over 2 into 2. A is equal to 2 plus 30 minus 1 into D. Our common difference is 7. Now, if you put that in a calculator, it will also give you 3105. Now, those are the two formulas that you can use. They give you the same answer. One just makes things simpler for you if you can find the last term. Now, in example 2, they say find the sum of the series -5 -3 -1 plus all the terms in between plus 123. Now, here we are given the last term, which is 123. If you have negatives like this, let's make it more simpler than us so that we get it in intuitive sense as to what does this mean. Now, a series is a sum of the terms, which means here we have -5 plus -3 plus -7 plus, and then there are terms in between plus 1, 2, 3. So here, if you have -3, is just we added a -3 plus a -1. Now, let's write down all the critical information of an arithmetic series. Do we know the first term? The first term is given by A, and then here it is given by -5. Do we know the last term? We do know the last term. It is given by 123. Do we know the number of terms in our sequence? We do not know, because we don't know how many terms are not written in between here. So we do not know the number of terms. Do we know the common difference? Now, we can find the common difference by taking term 2 minus term 1. Term 2 is -3 minus term 1, which is -5. So -3 plus 5 will give you 2. So we do have our common difference, and it is equal to 2. Now, which formula are we going to use? Do you prefer to use Sn is equal to n over 2 into 2a plus n minus 1 d? Or do you prefer to use Sn is equal to n over 2 into a plus l? Now, in each formula, we have every unknown except the number of terms. So we have to find the number of terms. How do we do that? Now, the interesting thing about this question is that we have the last term. So if we know the last term, if we find out what term is the last term, then we're gonna know how many terms our series has. So we can go to the general formula of the arithmetic sequence and say Tn is equal to a plus n minus 1 d, and say we know our nth term is 123. We know our first term is -5. We do not know the position of 123. That's what we are looking for, but we know the common difference. It is given by 2. Make the n the subject of the formula here, and we find out that 123 is term number 65. Now, if the last term is term number 65, that means that our series has 65 terms. So we know our n now. We can finally find the sum of our series. Now, let's start off with the first equation. The first formula, we are going to substitute S of 65 terms is equal to 65 over 2 using this formula into 2a is -5 plus n is 65 minus 1. Our common difference is 2. And then a sum of 65 terms in this series is equal to 3,835. Now let's use this formula to see if we get the same sum. Now we're going to be finding the sum of 65 terms is equal to 65 over 2 into our first term is -5, our last term is 123. Now if you put that in your calculator, or you are smart enough to work it out, it will also give you 3,835. So both formulas are giving us the sum of the series.